Good afternoon, class. Today we will be dealing with the occurrence, extraction, and uses of group 15 elements. These group 15 elements include nitrogen, phosphorus, arsenic, antimony, and bismuth. We'll start with the occurrence. The occurrence of these group 15 elements. Now we'll start with nitrogen. Nitrogen occurs naturally and forms 78% of the Earth's atmosphere. It is found in all species, especially in amino acids, nucleic acids, and adenosine triphosphate. Let's go to phosphorus. Phosphorus is a fundamental constituent of animal and plant matter. Phosphate groups are constituents of nucleic acids, that is DNA and RNA. Around 60% of bonds and teeth are made out of phosphates. Phosphoproteins are available in egg yolk, bone marrow, and milk. Now let's go to the rest of the elements, which are arsenic, antimony, and bismuth glands. These elements happens mostly as sulfides. Now let's go to extractions of each one of these elements. We'll start with the nitrogen. Nitrogen is commercially obtained from air. Initially, air is cooled to estimate water vapor and carbon dioxide. Then it is repeatedly compressed to around 2,000 to 10,000 kilopascals and allowed to expand quickly. This causes the temperature to rise and fall. And finally, the air liquefies. Fractional distillation of liquid air allows separation of nitrogen, oxygen, and the noble gases. This extraction of nitrogen occurs in a process called fractional distillation of liquid air, and it is extracted through 5 chambers, which are purifiers, absorption towers, coolers, compressors, and fractional distillation chamber. In the first chamber, the air is allowed into the chamber. Then the dust particles is removed, whereby the clean air is allowed to go to the next chamber, which is absorption tower, which contains sodium hydroxide. And the function of this sodium hydroxide is to remove carbon dioxide. And now the air is then allowed to pass into the next chamber, which is coolers. Here, it contains temperatures of negative 25 degrees, which removes water vapor. Then the clean air is passed into the compressors, whereby it contains the temperatures of negative 200 degrees and pressure of 200 atmospheres. Here, the air is compressed under a pressure of 200 atmospheres. Repeated contraction and expansion of air under temperature of negative 200 moves the air into the liquid. The air which is in liquid form is then passed to the last chamber, which is fractional distillation chamber. Here, the air which is in liquid state is being heated into this chamber, whereby nitrogen distills off fast due to its lowest boiling point of negative 196 degrees centigrade, followed by oxygen, which has negative 186 degrees centigrade, then rare gases, which is negative 183 degrees centigrade. That's all about the extractions of nitrogen. Now we'll go to the extractions of phosphorus. Phosphorus is mainly extracted from the phosphate rock by heating it with sand and coke in an electric furnace to a temperature of around 1800 Kelvin. The non-volatile silicon dioxide displaces the more volatile phosphorus pentoxide, which is then decreased by coke. And we will balance the equation here, which is calcium phosphate plus silicon dioxide to form phosphorus pentoxide plus calcium silicate. Then phosphorus pentoxide is then reduced by the coke, which is carbon, to form phosphorus plus carbon 2 oxide. Now this is the diagram whereby we have the carbon lining, steel casing, phosphorus vapor plus carbon monoxide, carbon electrodes, fabric lining, slug tap hole, and charging tube. Now, the rest of the elements, which are arsenic, antimony, and bismuth, are extracted from their sulfides. Now, let's go to the uses of these elements. And we'll start with the uses of nitrogen. Elemental nitrogen is used to form an inert atmosphere in the iron and steel industry. It is employed in the packaging of processing foods and to pressurize the electric cables and telephone wires. It is used for freezing of foodstuffs and preservation of biological specimens. Let's go to uses of phosphorus. Red phosphorus is employed in matches and fireworks. It is used as a component of the phosphor bronze alloys employed for making the bearings. Phosphoric acid is employed in fertilizers and cleaning of metals. Sodium tripolyphosphate is used in detergent, sand, in softening of water. And the rest of the elements, which are arsenic, bismuth, and antimony, are used as metal alloys. Now we'll go to the summary of this presentation, whereby we'll start with the occurrence of these elements, and we'll say that nitrogen occurs naturally in air, and it occupies the largest part of the air, which is 78%, and it is specifically found in amino acids, nucleic acids, and adenyl triphosphate. And phosphorus, being a constituent of animal and plant matter, its phosphate groups are constituents of nucleic acids, that is DNA and RNA. It is found at around 60% of bones and teeth are made out of phosphates. Arsenic and antimony and bismuth glands happens as a sulfide spores, which are stephenite, arsenopyrite, and bismuth glands. Now, nitrogen is extracted from air through 5 chambers, which are purifiers, absorption towers, coolers, compressors, and fractional distillation chamber. And nitrogen pass through these processes, whereby the first process is purifier, whereby the dust particles is removed, and the air is then passed to the next chamber, which is absorption tower, which contain sodium hydroxide or potassium hydroxide. And the function of this potassium hydroxide or sodium hydroxide is to remove carbon dioxide from air. Now, the cleaned air is then passed to the coolers. Here in coolers, we have temperatures of negative 25 degrees. This is the purpose to remove water vapor. Then the air is then passed to the compressors. Here we have the temperature of negative 200 and pressure of 200 atmospheres. Here the air is contracted and expanded under the temperature of negative 20 degrees centigrade to cool into liquid form. After then, we will pass it to the next chamber, which is fractional distillation chamber, whereby this air is then heated and nitrogen distills off fast, since it has the lowest boiling point of negative 196 degrees, followed by oxygen, which has negative 186 degrees centigrade. Then rare gases negative 183 degrees centigrade. Then phosphorus is being extracted from rock by heating it with sun and coke in an electric furnace at a temperature of around 1800 Kelvin. The non-volatile silicon dioxide displaces the more volatile phosphorus pentoxide, which is then decreased by coke. Let's go to uses of these elements. We'll start with the uses of nitrogen, whereby we say that elemental nitrogen is used to form an inert atmosphere in the iron and steel industry. It is employed in the packaging of foods and to pressurize the electric cables and telephone wires. It is used for freezing of foodstuffs, preservation of biological specimens. Let's go to uses of phosphorus. Red phosphorus is employed in matches and fireworks. It is used as a component of the phosphor bronze alloys employed for making the bearings. Phosphoric acid is employed in fertilizers and cleaning of metals. Sodium triphosphate is used in detergent, sun, in softening of water. The rest of the elements, which are arsenic, antimony, and bismuth, they are used as to manufacture fertilizers. They are used as metal alloys and to manufacture detergents. Come to the conclusion of this presentation. Let's meet in the next class.